to tell the difference between observational studies, surveys, and experiments. Now, let's say that we want to know whether listening to classical music makes you smarter or improves your grades. 30 years ago, there was a company who claimed that playing Mozart to newborns made them smarter. So, you decide that what you want to do to figure this out is to interview some friends. What variables might you want to record? Well, do you listen to classical music? Is that quantitative or qualitative? Quantitative or categorical? We answer with words. Has to be categorical. Did you listen to classical music while you were studying for your last test? What was your last test grade? So those are the variables that we might consider. Now, what kind of study might you do? In a census, we study every single person, but the first thing we have to do is define the population. Maybe we're talking about every high school student in Round Rock High School, every student in Round Rock ISD. We define the population first. Very important. This is a mathematics discipline. We must be specific. Okay, so we're performing a census every time we collect data from every single individual in the population. When that's not practical for whatever reason, we just sample. We perform sampling when we collect data from some well-chosen individuals in the population. Now, sometimes we want to collect actual data. With an observational study, this says we let subjects choose their own treatments. We just watch what happens, and we record the results. One example I gave in class the other day was to say, if I want to find out what kinds of lunches students prefer, then we might stand in the corner and just record how many students pick salads, how many students pick pizza, how many students choose the hot meal. Observational studies do not change the variable being recorded. Now, observational studies do have the advantage of recording the data and determining whether there's an association, but that does not imply causation. Why not? Because the only time we can ever determine causation is when we are doing an experiment in one of the physical sciences, and it can be endlessly reproduced and reduced to mathematics. Why do we not imply causation? Let's look at the classical music question. What might people who listen to classical music have in common with people who have good grades? Well, maybe they're more highly educated. Maybe more education leads to classical music and good grades. Well, or maybe they listened to Mozart when they were kids. Ha ha ha, I'm kidding. Okay, this is very important. A lurking variable can be the cause of both effects. Lurking variables are very common. We have to be aware of them, and it's very difficult to identify possible lurking variables. Okay, if you really want to determine correlation, then you randomly assign subjects to the different treatment groups, instead of letting them choose. So we record that. Sometimes subjects are assigned to a fake treatment called a placebo. Even though the placebo has no impact, subjects still might feel better because of the placebo effect, which has been studied for more than 70 years. The mechanism is still not understood, but it exists. It's at least 20%. In some situations, it's as high as 60%. By randomizing and using placebos when possible, we can control the impact of lurking variables. We can't eliminate the effect of lurking variables, but we can control it. Okay, in order to validate the results of an experiment, it is important to replicate the experiment, do it more than once, to see if the results are repeatable. You always know that you are dealing with an experiment when you have two groups and you treat them differently. Could be more than two groups. The key to knowing that it's an experiment is you're treating the groups differently in some way. Okay, one form of a virtual experiment is called a simulation. It uses a mathematical model and frequently computer work to virtually model the situation. The weather predictions have gotten much, much, much better in the last 30 years because the models have improved and the computers have become more powerful. Okay, we can do simulations with random number tables. Maya Moore is a professional basketball player in the WNBA. She's amazing. Her free throw percentage is 86%. Now, how many free throws might she make in 10 attempts if we use a simulation? Well, first we have to assign the digits. Okay? So we assume that 1 through 86, she makes the free throw. 87 to 99 is a miss. So now what do? The first two digits are 92, she misses. Next two digits are 21, she makes it. Third two digits are 7, she makes it. 04, she makes it. 39, she makes it. 08, she makes it. 62, she makes it. 97, she misses. That is how this works. In this simulation, 7 out of 10, well within the range of normal for her. Okay. If we use a table of random digits to simulate airline passengers chosen by TSA, we assign digits. The TSA goal is 10%, so we take 10 digits, 9 of them, no additional screening. The 10th digit is a screening. Now, do we have to assign the digits exactly this way? No, we could say 0 through 8 is no extra screening, and 9 is a screening. It does not matter how we do this. However, it is vitally important that you assign the digits before you begin to run the simulation. Otherwise, you're introducing additional bias. Write your summary of today's lesson on the separate assignment in Schoology, and thank you for your time.